our audience is in great luck. We managed to get Eric to give a talk about Filecoin mining and his miner, Big Chungus TM. Eric, why don't you go ahead and turn on your cam and mic and join me on the main stage. Hey, Eric.
Yo, what up? I'm gonna give a quick, little TLDR of storage and mining. I'm not going to go too in depth about this because we have a lot of great speakers speaking about Filecoin throughout this week. But at a very high level, storage mining is almost like a useful proof of work. If you go a little technical, the analogy breaks down pretty quickly with expected consensus and pre-base time and all that good stuff. But at a high level, it's similar. In traditional proof of work networks, your I guess your power on the network is dictated by how much hash power you have. How much hash power you have is a function of how many GPUs you have, ASICs or whatever, right? In mining and on Filecoin, power is a function of how much hard drives you have, kind of, or more concretely, how much storage you're able to provide to the network. So storage mining is like very easy to do simply, but very hard to do at scale, very solidly. So, I mean, that's kind of the nice thing about storage mining on Filecoin is that, kind of anybody can get started. It's not like Bitcoin where you have to go to like some sketchy website and buy like these little ASIC things and Bitcoin and then mount them on this like shady rack somewhere in your closet. With storage mining, all of this is can be done, or rather has to be done on regular hardware. So CPUs and GPUs that you buy from Canada Computers or Amazon or something like that. There's like no real way to do this using like ASICs. So Big Chungus is, in the class of what we call small miners, despite our name Big Chungus. And, we've kind of proven that, small miners can, participate effectively in the network. And yeah, that's been, I guess, what's keeping us going. And it's just fun to participate in such a big network. I think it's like at 1 exabyte or something like that. Like I don't even know how big an exabyte. I can't even picture how many hard drives that is. But we're a small fraction of that and contributing storage to that. This is kind of like a high level, basic level, mining, or of a miner rather. So it starts off with mining either accepting deals or pledging committed capacity. So to accept deals means to accept files, a price associated with a file, somebody who's willing to pay you, store their files on your system, which is kind of the basic idea of Filecoin. And so when somebody when that deal gets accepted and you've accepted the terms and conditions of it, so the price and the time to store it for, you go to what's called the pre-commit phase of mining. This is also kind of known as sealing. So what happens during this phase is it goes through this algorithm which takes this sector of data and then creates a unique replica of it. And the unique thing about this process is that it's not parallelizable. So all of this happened on one CPU core, and it has to take a lot of time. That's kind of by design. Currently, sealing takes around 4 hours to do per 32 gigabyte sector. And there are developed recently that have brought it down to 2 hours, which I think, this is just what I've heard, but I'm not entirely sure. I think that is the theoretical for, for a regular CPU. So after you've created this rep of this 32 gigabyte chunk of data, you go what's called the commit phase of the process. And during this phase, you compute a snark of this and you commit it onto to prove that to prove to the network that you correctly run the sealing process. Obviously, after that, you're kind of good until 24 hours later. So every 24 every miner will have to complete a challenge, and the challenge is called a window post. Post stands for the FaceTime. So every 24 hours, call will ask you to snark proof of a random sector that you've committed, and sure that are in fact not cheating and deleting sectors after they have sealed them on their hive. So this ensures if you've accepted a deal to store data for like 2 years or 20 years or whatever, that you're in fact doing that and not cheating everybody out. So just to go back with the pledge deals and pledging committed capacity, instead of accepting deals, you can also do as just to kickstart yourself is to pledge committed capacity. What this essentially means is that you have the ability to store data. So you're at this phase, you're kind of sealing these random bytes of data and upgrade later to store actual useful data. So yeah, that's kind of like the basics of a miner. There's obviously detail, tiny other things that you have to factor in as well. But at a high level, this is kind of what happens. So I'm going to talk a little bit more about Big Chungus in particular. If you look at that beautiful picture there, that's me and David all decked out in our summer gear at the office. And that is our mining rig. When you normally think of mining rigs on blockchains, you think of like these gnarly racks with like 20 GPUs screwdrivered onto like a little metal frame thing. It's really scary to look at, and then like wires hanging out of everywhere. So those are our 3 rigs that we have for mining, and each of those rigs things, which I'll go into a little bit more detail in a second. So first off, I'll talk about our storage rig. So this machine, as you can see there, is the machine where we keep all of our storage. This machine has in it, and each hard drive can store 14 terabytes of data. So that's a lot of hard drives. It's actually a very, very heavy computer. So we have all these drives in RAID Z2, which gives us effectively 150 terabytes of usable storage capacity. Regular, off of Amazon Ryzen 7 processor that we got for like a few $100, 120 gigs of RAM, and over 10 gigabit Ethernet. So, I mean, as you can see here, like just very basic stuff that you can get off of Amazon. In our sealing machine, so this is the is in charge of the very CPU heavy tasks about before with the generating the replicas. So during the pre-commit phase. So this is the most specialized hardware we have, and it's not even that specialized really. It's like stuff you can get off of basically shops. AMD server processor in there, the EPYC 7F32. Over the summer, we had to like buy it off of like from Italy or Germany or something like that. But yeah, now that you can find them anywhere. This was 512 gigs of RAM. Has some NVMe drives, a little graphics. And yeah, our machine can seal around 6 sectors at a time. That's gigabyte sector, 180 something gigabytes at a time. Am I even doing my math right? 196? Something like that. So yeah, for this it's a dual socket motherboard, so in the future we can actually expand that and probably do like 12 or 14 sectors at a time. And then we have our snark box, which is in charge of the commit phase, the life cycle of mining. And this has very, stuff. It's just like an AMD Threadripper in there. And we have 2 GTX 2080 Ti. So during the generating snarks, you can very much benefit from having to do, like the computational proofs. So that's why we have 2 of these graphics cards in here. Just C1 in around like 40-ish minutes per sector. You can hardware. And so that we see this, pretty small setup. So we participated in Filecoin's Space Race 1. And during those 2 weeks, was it, or a month? I actually don't remember. It's like during the summer, and as serious. Those few weeks, we still terabytes of capacity, and we've had of 99% and a retrieval success rate of 100%, which is very good numbers. We have enterprise level internet, enterprise powered machines off of one socket in the wall, 100 bit. We just have regular residential internet. Pretty impressive, in my opinion. And as of today, we have 21 terabytes of storage committed, and just to show you that actually make money now. Grants us a total of 110 Phil in total rewards, and obviously that's we're only gonna get more. We're only gonna mine more blocks. So an interesting thing to see here is our power change graph. So this power change is essentially the growth of our miner and how much it's committed to the network over time. So as you can see, it's quite linear with some in between. These are, just stupid failures on our part while we're running it during the incentivized testnet. And recently, Filecoin has some issues with, very high gas prices, like basically every other blockchain. But sometimes we have trouble getting our messages through the message pool, or what most people know as like the mempool. But we've recovered quite well from it. We've recently set up logging infrastructure and alerting and all of that. So I don't stay up until like 4 a.m. Just refreshing this miner page anymore, or checking or SSHing into our node. Now I stay up until 4 a.m. watching YouTube videos instead. So yeah, at first Big Chungus was kind of like, a hobby project that we kind of did for fun, but, very quickly we realized Big Chungus is actually quite important for, our organization and, a few of our teams. As, Austin just talked about, our team is working on Rust, which is the Rust Filecoin implementation. And obviously, he talked about the importance of having multiple different implementations on the network, but we also kind of want to differentiate ourselves from the other implementations as well, and provide offerings that that a reference implementation like Lotus might not consider doing, because their goals are very much different from our goals. So Big Chungus was a very good opportunity for us to explore different stakeholders in the Filecoin ecosystem and understand other needs when building, software for Filecoin, and obviously in particular the miner ecosystem. So me and David, we've learned a lot from this whole project, and this will obviously translate very well into how we build Forest, textures that we choose, and the next iterations of Forest. Yeah, Austin should have talked about some of this a few minutes ago. We're also working on, like Big Chungus is also going to be quite useful for when, we're testing out our Retrieval market stuff that I think David will probably talk about sometime tomorrow, David or Elizabeth. They're working on very cool stuff related to secondary retrieval. Big Chungus will play, a big role in tech for those, for all of the Filecoin software that we're. So yeah, that's kind of the future for this. Providing support for other Filecoin projects that we're building and learning more stuff about being a miner. Right now, a storage miner, and then hopefully also being a retrieval miner. Yeah, that's kind of it. There's a picture of me and David again. If there's any questions that you have related to Filecoin mining, being a small miner on Filecoin, and how to get started and all of that, like definitely hit me up on Twitter. Link is down there. Please like, subscribe, check out the comment section. Yeah, that's it. Thank you.
Awesome. Thank you so much, Eric. I know it was last minute, so we greatly appreciate your participation. It was a great presentation, and I think we all appreciated it.
Yeah, no problem. This is fun.
We do have a couple questions for you in the Q&A. First question, what was the hardest part to source?
Yeah, I mean, the hardest part to source was definitely that AMD EPYC CPU. It was, I think it came out officially in April or May or something, and we started building this in July. And dude, like the whole supply chain in computing is like a mess right now. It's like impossible to find a lot of CPUs or GPUs. And so the special thing about these 7F series CPUs is that they are the high frequency equivalent of a lot of the AMD EPYC line of CPUs. And the reason why you want a high frequency CPU for this is because, like I said, during the sealing process, like things cannot be parallelized. So it means if you have to do things sequentially, you better be able to do them really fast. So these were impossible to get. We had to, like I said, we were looking on eBay. We bought it from like some random store in Germany. It's just funny. But yeah, that was probably the hardest part to source. I think they're much more readily available now. I saw them a lot Canadian retailers recently, so yeah, it shouldn't be too much of an issue anymore, hopefully.
Awesome. This question just jumped up on our board and got many votes really quickly. What's the story behind the name?
There really isn't any story. I think Big Chungus has just kind of been a meme that we have at ChainSafe among a few of us. We just call each other Big Chunguses, and yeah, I don't know. It's just a funny meme. Like, it's funny. Like, don't you think it's funny? Just a fat bunny.
Awesome. In hindsight, what parts would you have bought differently?
Yeah, I mean, that's a good question. Certainly, so within our storage box, right now we have a motherboard that has like 3 PCI X16 slots. We really should have tried harder to find a motherboard with 4 PCI X16 slots. So 3 of those slots right now are taken up by SATA controllers. I kind of want to throw in a GPU in there, but it's like I can't because there's not enough slots. And the reason why I want a GPU in there is to do these 24-hour proof of spacetimes faster. Right now, every 24 hours, our CPU is bursting up to 100% on all cores, computing the snark proof. It's like, I mean, it's doable, but it's just a little uncomfortable. It's like very much possible to miss a deadline by accident if it takes a little bit more time. Also, I guess another choice. I mean, this is not something I would have done differently because we didn't really have an option. But kind of like 2 or 3 months after we bought all 3 of those 2080 Ti's for a lot of money, the 3000 series GPUs came out. So it was kind of that kind of hurt a little bit, but not so much because it's possible to get your hands on those anyways. So yeah.
Last question for you. Do you plan to use Forest on Big Chungus?
Oh yeah, 100%. As Forest becomes more production ready and ready for testing, we're gonna swap out Lotus for Forest. I mean, if you're building something, you better put your money where your mouth is, right? We have real money sitting on these machines, and we're building software. And if we can't trust our own software, how are other people supposed to trust our software? So, after we're ready to release Forest, after it's all tested and productionized, we're swapping. We're gonna slowly start swapping out all the Lotus components from our system and putting in Forest. In the future, when we build our implementation of the storage miner in Rust, like gonna swap that out as well. Yeah.
That's awesome. Thank you so much, Eric. It was a pleasure. I know you're busy, so thank you for taking the time.
Thank you for having me.